Hello and welcome again. Thank you so much for being around. Thank you for joining us in today's class. Now we have previously had topics, exponential equation, indices, and also we've had logarithm. Now we suspended logarithm and we're starting with this. Now later when we go back to logarithm, we'll be going into logarithm of common numbers or common logarithm. But then let's look at surds. Now we've dwelt long in logarithm, so I thought to give it some time, go into another topic. They say variety is the spice of life. So let's do something else, we'll go back to it now if you don't mind. Now let's look at surds. Now we have here surds. We're going gradually. Now what are surds? Now surds are rational numbers that cannot be simplified. Irrational numbers that cannot be simplified, that cannot be made rational. Now you have to ask yourself, what are rational numbers? What are irrational numbers? Now first of all, rational numbers you want to ask, what are rational numbers? Rational numbers are numbers that can be expressed in fraction, and it won't really change what they are. They can appear in a form that doesn't look exactly like how you know them, but it's still the same thing, appearing in a different way. The same number appearing in the same number. So rational numbers are numbers that can be expressed in a form of fraction. So if rational numbers are numbers that can be expressed in the form of fraction, that means irrational. You know, ir means the opposite. E-I-R, irrational. It means not. They cannot be expressed in fractional form. Now let me give you an example of rational number. Rational numbers, example, your 2 is a rational number. Now rational number can be example of whole numbers, like whole numbers. Example, you have 2, 4, 7, 21, etc. It can also be in form of decimal numbers. Can be decimal. For example, now 0.75 is a rational number. 0.5 is a rational number. Now you ask me, how is this one? It can be expressed in fraction. Now let's do it. What is 0.5? 0.75. Oh, let me bring it up a little. Now I've done these whole numbers and decimal numbers. Now as whole number, okay, let me use here and I'll come back. I'll come back to this place. Now if I bring 0.75, 0.75 is the same thing as 1275 all over 100. Which number is common that can divide here? Divide here is 5. If I divide both sides by 5, what do I have? I'll just go down. I'll just go straight. Use 25. But let's use 25. 25 can go 25 here, 25 here. 25 into this is going to give us 3 times. 25 will go here 3 times. 25 here will give us 4. So 0.75 is, as a decimal, can be expressed as a fraction, which is the same as 3.4. In other words, also, you can do the reverse. You can turn this one to decimal by simply doing what? 3 divided by 4. Which is what? The same thing as surds. What to do in surds. Now, we'll come back to this. This is a typical example of basic forms in surds. That is, you moved from a number that has at least one of the digits that comprises them or that make up them can be, you can find the square root of them, can be rooted. And this, for example, now, this is the same thing as saying 16 times 3. which will give you this, the square root of 16 times 3. So that's just it. Now, having said this, and this one also, 0.5 is a rational number. 0.5 is a rational number. The same way this way, if I look at it, 0.5 is the same thing as moving because 5 over 10. And what is 5 over 10? 5 here, 1, 5 here, 2, 6 times 1 over 2. So 0.5 can be expressed in a fraction. That is why 0.5 is a rational number. Also, half is a rational number. So another example of rational number are even the fractions themselves. Like we have, this one is 3 over 4, and this one is what, 1 over 2, and you can have them etc. Now, the thing is this, rational numbers are numbers that can be expressed in fractional form. Now, that is just by the way. I was trying to explain sorts. I said sorts are numbers that cannot, sorts are numbers that cannot be simplified into rational numbers. For example, now these two, good, look at the example. Now, 2 cannot be expressed like these 2. Now, if I try to find the square root of this, it's going to give me a number that is not ending. If I use a calculator or anything, or any instrument, to get the square root of 2, it's going to give me a set of numbers that is not ending. The numbers keep on continuous. And at the same time, it's not repeating. For example, non-repeating can be, example, a repeating decimal can be something like 1, 2, 1, 2, or let's say you have something like 4.121212. Now, this is repeating. But this one's any digit or any expression that does not give you a terminating answer, or even if the decimal is at least it's repeating, is a non-rational number. So they cannot be expressed in exact fraction or decimals that terminate. They don't end, they don't terminate, and they don't repeat. So these are typical sorts. So again, sorts are numbers or irrational numbers that cannot be simplified to rational numbers. Now, in the process of solving logarithm, almost every question I defined logarithm. The log of a number is the log of a number to a particular base is the number of times the base will be raised to give that number. Now, the definition of a thing helps you understand it almost all the time. It's so in science. Know the definition. I want to tell you as a student, try to know the definition. Don't just cram things. Know the definition. So having said this is the definition of sorts. I have taken time to define it because we're going to be using it as we progress in this. Now, another thing is this. Why is it that we call it sorts? The history has it that sorts came as a result of having this set of numbers that when you want to work on them, they are not ending and they are not repetitive. Because they are not ending, the Indians look at them and give them something in term that looks like this is not responding. And then the Arabians also looked at this set of numbers, irrational numbers, as deaf. They are not responding. And then Europeans, the same thing. These are what? Not responding. They don't terminate. They don't repeat. So because they don't terminate, they don't respond, in quotes, they were called Surds. And this word Surds is actually of Latin origin. Now, Latin was predominant several years ago, like decades ago, even centuries. Now today, English is the most dominant, is the lingua franca in the world. Then Latin was. Now, Surds, it is from Surds, we get the word sorts. Now, what is Surds? Means mute, silent, not responding, deaf. So, sorts are irrational numbers that are deaf. They are not responding. They are not ending, non-ending, and non-repeating. Now, I'm taking time to go this. I never knew I was going to take time to explain what we have here. But for the length of the video, I would like to stop this. Now, the reason why I always consider the length of the video is because of the attention span these days. Most people would not want videos that are long. However, some may. But, okay, I don't know how long we've done already, but, okay, let me quickly go into the rules of Surds. Now, when we did indices, I considered the rules of indices and also considered the rules of logarithm. Rules are important because they are like the gateway. If you obey it, you will pass. Or your ticket. If you obey, you will pass. You will go to the next, you will go to the next, you will go to the next. And Surds don't have so much, just about two of them. They're about to go to be looking at here. Now, it's simple. The rule number one is this. A number multiplied by a number, an irrational number multiplied by a rational number, square rooted or cube rooted, is the same thing as writing it this way. For example, now, A times B is the same thing as what? A multiplied by B. And it's still the same thing as writing it as A, B. Some people may want to put a dot signifying the multiplication side. If I use digits here, it's going to be, for example, 4 times root 4 times root 9. It's the same thing as doing it as 4 times 9 and the same thing as say 4, 9. No, not decimal point, let's say like this, right? What is 4 times 9? Now, whichever way I can solve it, I can solve here and get the answer. Solve here and get the answer. Now, what's the answer here? If I decide to move here, I can say the root 4 is what? Root of 4 is 2. Square root of 4 is 2. Square root of this is 3. The times should remain. So 2 times 3 is what? 6. If I come here, I can do the same thing. 4 times 9 is what? 36. And what is the square root of 36? 6. So you now see this gives us the same answer with this. So this is rule number one. The rule number one again states that use any digit. C, the square root of C times the square root of D will give you both square rooted C times D. In the next class, we'll look at rule number 2. Thank you so much. Now, if you gain value, you've been gaining value. Please like, share, make a comment, ask a question, and also subscribe. Now, why don't you try your hand on this before the next class? Just try to see if you can do this, and then move on. Thank you so much again. Next class.